All right, my PHS algebros. That's great. Let's take a look right here in terms of considering this these two functions running into each other. It is nice that they already give me that point there of 10 and 4. So I already have one of the points of intersection, right, Cameron? There it is. We have a linear function as identified by f of x, and a parabolic function is identified by g of x. It is not starting at 0, 0, even though it looks like it's pretty close, so you can't use that. But we do know that the vertex of it is 6 and 8 because we can read and we can see that it actually identifies that it is a vertex. Go a little bit too hard in the paint sometimes. I'll pull it back a little bit. So all that to say, I have that point, I have this point here. In terms of identification, step one, let's label the things that we know. Don't know A, but I do know H, I do know K, and I know that I also have a point as well to kind of get started with. Your tests on this guy, you won't have to find the rule. This is more just kind of like a little bit of a midterm review before our midterm review. But we know that this guy is going to be in vertex form, so we are going to second find the rule of this guy in our vertex form. Starting by plugging in the point and the HK, so 4 is equal to A, 10 minus 6 squared plus 8. And then see if we can solve for that guy there. Always get the 8 out of the way first. Negative 4a, I'm then going to end up with 4 squared. Negative 4 is equal to a times 16. All right, this should be prettier now that we're dealing with a quarter. So a is equal to negative 0.25. Taking a look at the diagram again, I always do this in terms of like a little validation. We all need a little validation sometimes in our lives. So, no, nothing. Okay. With this, I know that my parabola is facing down. It's good that my a value is negative. Our objective in this is really just to find point Q because we already have P. But we know there's only one approach to this guy in terms of like our points of intersection. We have the option of substitution and or comparison. But because we have both rules, so negative 0.5x plus 9 and negative 0.25 x minus 6 squared plus 8, because I have them both set to y, I'm obviously going to choose to use comparison in this case, right? So we are going to compare one to the other. So y being equal to y, I'm going to set the linear on the left-hand side, and I'll put the quadratic on the right-hand side. I've said it before, but I'll explain it again. What is the purpose behind all of this? Or why is it that I can do this? It's because for points of intersection, we have two functions that we know share 2 points, like that exist within their functions. Like when y is 4 for the quadratic, that x will be 10 for the linear and the quadratic. So that 10 and 4 is on both of those functions. So if we can kind of set these up in a way where their y is equal to y, at that point, we know we're going to be able to find out the x's because they're shared points of intersection. We're not shared points of intersection, but they're shared points. Let's call it that way. So where did most people struggle with this the other day? FOIL first. And I'm going to do it quick, and I'm hoping you can get at that point too, is to leave this side alone for now. And then on the right-hand side, x squared minus 12x plus 36, and then plus 8. The other thing that people will screw up now is they'll add 36 and 8 together. They forget that those are still in brackets and that negative 0.25 is outside the trinomial, x squared minus 12x plus 36. But we have to distribute that first before we go anywhere else. So leaving the linear alone for now, negative 0.25 x squared. What's 1/4 of negative 12 if not 3? And then what's negative a quarter of 36? I should have negative 9 plus 8. Combining these two things together here, we're going to end up with negative 1. I am now going to actually just bring over the 9 and the negative 0.5x. So we can set this side to 0. And in fact, I'm going to write that down there just to be clear. Our objective here is to set to 0. We do that so we can either factor or quadratic equation it. That's kind of the main purpose behind all of this here now. Scroll that up. I can then from here, so set to 0. The x squared is not going to change because there's nothing to actually bring over to combine it with. We'll be adding the 0.5x, so it's plus 3.5x. That negative 9 and 8 became negative 1. When I bring the 9 over, I'll be subtracting it, so I'll end up with negative 10. In terms of factoring this out, you can either, again, factor or quadratic equation it. If you are someone that does really enjoy the factoring part of it, I can give you a little bit of a hint and guidance if you wanted to try it. What if I multiplied everything by negative 4 across the top? I would end up with a positive x squared, a negative 14x, and then a positive 40. I'll say that again. If you prefer factoring and you want to see if you can do it, I can modify the proportions of an equation. In fact, I also don't like it when my a is negative. It just makes factoring harder. I also don't like it when my a has a coefficient in front of it. I'd rather that just be 1 because it makes the factoring oh so simple. Now, I'm hoping when you look at this guy here, if you were the factoring type of person, what plus what is equal to negative 14? What times what is equal to 40? Think about your factors of 40. What are the ones that would work, right? You can start to list them like 2 and 20, negative 10, negative 4. Hopefully you see that right off the bat. Negative 4, negative 10, negative 4, and negative 10. Will this work every time? No. But is it worth just trying to see if you can turn it into something that is easily factorable? I believe so. Yeah.
How would you foil which part
Like this here to there? Or the foiling up there?
Yeah.
So I'm just foiling the x minus 6 squared. So I'm just saying with itself. So it's saying x minus 6 squared. So technically speaking, what's happening there is just that. So I will do, I'll scroll it up. First, x times negative 6, negative 6 times x, negative 6 times negative 6, right? So, again, this is nice because I'm going to end up with two options, x minus 4, x minus 10. I can actually solve for x minus 4 is equal to 0, x is equal to 4, x minus 10 is equal to 0, x is equal to 10. I can ignore this one because I'm pretty darn sure that's going to be the one that turns into 10 and 4. That is my point P, meaning this is going to end up helping me find point Q right there. So the last and final step of all of this, because again, our objective is just to find point Q, is to go ahead and plug it in, and please just plug it into the linear. So for your fourth and final step here, plug in x and find y. So y is equal to negative 0.5x plus 9. We're going to then take that x value that we just found here, plug that in, negative 0.5 times 4 plus 9. So I'm going to end up with negative 2 plus 9, y is equal to 7. And that means point Q is 4 and 7. And if you go back up to the diagram, does it make sense that the y is higher on that than point P? Yes, it does, because it's going down. So we can kind of validate that. just through the diagram itself. But this is probably a better example right here. I'll leave this up for a second, pause it, and then kind of review some of those picture problems there in a second, just because I want to include that all in the same video. So let's take a look at these guys here. We're just going to look at this setup of them again. For those that may have missed this or the explanation for it, I'll do both of them and then kind of walk through how to solve at least this guy here. These are like kind of weird, like picture combo, sentence combo ones. Sometimes they'll give it to you as an image to try and decode. Sometimes it'll be a sentence. Sometimes it'll be both. Your goal is to find the width of that. It tells you in here, if you read through it, that it's a combo of rectangles and squares. But they're unknown lengths. The square is an unknown size. The rectangle is an unknown size. So in terms of making these guys, and this will be true of the long answer one you have on the test as well, you have to start to label things that are unknown to you. And my advice to you is if you see a square, I'll say this slow and clear. If you see a square, that's the guy you're going to label as X. Not to say that it won't work if you label it as Y. It's just, do you really want to work with Y squared when you can work with X squared? You know, more of just like a process for you to think about. So as I go through this, those are all my unknowns. And there's going to be two different equations here. So number one, I want you to like label the diagram. Label the diagram. And then what I want you to do is take a look for something like this here. Is there something on the diagram that I could maybe turn into an equation? And so we are going to write out the equations, and there's always two. There are linear equations, and there are quadratic equations. Now, in terms of your decoding, linear is either going to be mentioned in like one-dimensional length or perimeter, right? Length or perimeter is going to be the indicator that we're dealing with a linear function, because like the exponent on x is just going to be 1. So let's look at this here. For length, it's saying here, if this was a sentence, length of that wall is 310. So x plus x plus x plus y, 3x plus 2y is equal to 310. That's the only hard part of this, is to be able to see that. X plus x plus x plus 2y is equal to 310. We then look at our linear, or our quadratic, and say, well, what's going to indicate to me that I'm dealing with quadratic? It's either going to say area, or it's going to say meter squared. Okay? Area and or meter squared. Or centimeter squared, or something along the lines of that. So, measurement squared, like that. So it then says that the total area is 6 squares and 5 rectangles, and that the total area of 6 squares and 5 rectangles that Margaret painted is 36,244. So how do I find the area of a square, if not go side by side? So there are 6 squares. Side by side is x times x, or x squared. There are 5 rectangles. Let's add that area to it. The area of that, well, the height of that rectangle is x. There's my length. There's my width, or the other way around, whatever you want to call it. So rectangles are length times width. I know that I have an unknown x, unknown y as the length and width, and that combined, that would equal 36,244. Once you have this, your idea will be to inject one into the other. A lot of the exam types, you're going to end up doing substitution, because turning these words into rules, it's going to be messy. Turning the words into the rules, I'd rather you just try and isolate for basically the y and then sub that guy in. If you're doing substitution and we're subbing into a quadratic, try not to solve into the x squared, because it usually just makes things more complicated, right? Because then you're going to have to FOIL that guy, make it like ugly. So if we can, rearrange this guy here, negative 3x plus 310, divide by, y is equal to negative 1.5x plus 155. Where are we going to go from here? Well, step 4 is going to be our actual substitution. Okay? So I'm going to sub this guy here in to that spot right there, being left with 6x squared plus 5x, and then internally negative 1.5x plus 155. And then equal to 36,244. Really, we're just trying to now expand and solve and find our a x squared bx plus c. So we're trying to turn that into, right, 0 is equal to ax squared plus bx plus c. Your goal is to set to 0. Doesn't matter what side, right? So in this case here, I'm probably just going to FOIL that guy throughout. Then I'm going to take a look at this guy here, bring the 36,000 over, and I'm going to be stuck with the quadratic equation, right? Like, I don't know if I'll be able to factor this guy. I'll try. Lord knows I'll try. Because then my 5 times 155. Oh, write that in. So 6x squared minus 7.5x plus 775 minus 36,244 is equal to 0. Oh, he be x squared, he be x. My bad. Thank you. So when I distributed that guy throughout, these two get conjoined together. The 775 stays alone, and the 36,244 stays alone. So we end up with negative 1.5 x squared plus 775x minus 36,244. No. Oh. What am I? No, that's ugly. I tried dividing that 36,244 by negative 1.5, but it doesn't give me anything pretty, so. Yeah. So then now our objective here is A, B, C. So quadratic equation. So this is pretty common, pretty standard. From here, you're just going to kind of work it out and solve for it. That's basically it in a nutshell. I'll finish this here in a second when you guys are gone for the next group. So just to continue this out, we use our quadratic equation. We are going to choose negative 775 plus or minus square root of 775 squared minus 4 times negative 1.5 times negative 36,244, all divided by 2 times negative 1.5. My focus on doing these guys here will always be to do this, including the square root if I can, all in one shot with my brackets. So square root of, I'm going to do like multiple brackets here, 775 to the power of 2, close bracket, subtract, open bracket, I'm going to go 4 times, and then we're going to make it a negative 1.5 times negative 36,244, close bracket, equal to, and it gives me something like 619, something pretty like that. So hopefully you can become proficient at your calculator where you're going to end up with something nice like that as well. Reason being is it just makes the calculation process easier. You're letting the calculator do the bulk of the work, specifically with the subtracting of a 4 times a negative times a negative. Most people kind of make a mistake there. this guy would still stay as a subtraction because you would be subtracting a positive value. But if it was only the 1.5 that was negative, throws things off, makes things a little bit more challenging. But here we are, splitting off into 619, so negative 775 plus 619 divided by negative 3, and negative 775 minus 619 divided by negative 3. We're going to have both of these guys here divided by 3 is going to give me something weird like 464.7 as one option for x. And then we're going to have something like 52, which is a prettier number to kind of work with there. But all that to say, we have two options: x is 52, x is 464.7. So if you're getting to choose, if we go back up here again in terms of like what makes sense, even though we could reject it because it's ugly and has a decimal, we can also reject the 464 because it doesn't make sense with this guy being 310 centimeters. That just doesn't necessarily work out. But it being 52, 52, we're somewhere in the neighborhood of being like 150 plus itch left over split between the two y values. So we can kind of get an idea of what we think the final answer will be. When we go to plug this guy in at the end, so again, we are going to accept and or reject a value. Obviously, we'll accept him based on the idea that there is no way one value of x can be larger than the full length. So we reject that guy there. And we're just going to plug it back into the linear function. In fact, I'm going to use the rearranged version. So last but not least, step 5 is going to be plugging it into the negative 1.5x plus 155. Let's throw that 52 in there and see what we end up with. So we're going to have y is equal to negative 78 plus 155. And we end up with 77. That story checks out, right? You can validate it by plugging it in, the x and the y into that function and see if it does kind of balance out. But we know in this case that it will. So at the end of it, you take the 77 and the 52. And then we kind of figure out this last piece here. So there are a total of 1, 2, 3, 4 x's. So 4 times 52 plus 1, 2, 3 times 77. Multiplying those things together, adding it all together in the end, 4 times, is going to give me a total length of 439. So that is going to be our final answer right there. This is a more challenging one. Of the two, I will also remind you as well, we kind of went over this yesterday as well. The yellow, as you can see on this, is what's highlighted. I'm not going to walk through this one in full, but I will tell you that with these two equations, when you see length, it's going to be a linear. So it was 2x's, the height of 2, the length of y would all equal 23. And then the area one is going to be my quadratic equation. In terms of the setup, we won't go through it in full, but I am going to isolate for this guy here first. So first step would be on this guy to rearrange that one to get y is equal to negative 2x plus 21. Brought the 2 over, brought the 2x over, make sure that negative 2x is, or the 2x is negative. And then we would inject that, so substitution, we would inject that into here. X squared plus 2 times negative 2x plus 21 is equal to 47. What is our objective? Our objective is to get ax squared plus bx plus c is equal to 0. We always want to set to 0 and then have a clear a, b, and c for either factoring or quadratic, which means we would end up with x squared minus 4x plus 42 minus 47 is equal to 0. X squared minus 4x minus 5 is equal to 0. I would probably just factor this guy here. Hopefully you'd be able to figure out what adds together to get you negative 4 and multiplies together to get you negative 5, right? We're going to have our negative 5 and 1, negative 5 and 1, meaning of the options, might as well just keep going here. Of the options, x minus 5 is equal to 0, x is equal to positive 5. I know I will be rejecting this one because, A, we can't have a negative value. So accept, reject, plug back in, and solve. Again, if you can factor, my goodness, does it ever make it easier? Look at the difference between these two questions. This one, I'm pretty well ready to be done. This one, as you can see, a little bit more work with the quadratic equation in there, and also you're dealing with uglier numbers. So depends upon the question that you get presented with, but hopefully this kind of explains everything that you'll need to know with regards to the actual test later.